The second objective is to come up with the amount of grams, okay, per can of Coke. In fact, let's just continue with this and keep this the same video. How am I going to do that? Well, the first step I'm going to say is calculate the mass of a 2-liter bottle of Coke. How am I going to do that? Okay, well, very simply, I'm going to go back to my data, okay, the mass of 2-liter bottle of Coke. If I go back to my Coke data, now I don't have any Coke data here and you don't have any of them, I'm just showing you how this is done, okay. Take my Coke data and let's just pretend, okay, the Coke density of my Coke data was, I don't know, 115.3 grams per milliliter. I'm just making this off the top of my tall head, okay? And let's say I convert to grams per liter, which we show the work. That's going to get bigger by 1,000. I made a mistake there. Clearly the density is not that big. That would be a metal. Okay, so this would be 115. So this would be 1.1153, and by the conversion, it'd be by 1,000 times, we're getting this bigger, 1,153 grams per liter, just like I talked about before. So this is a better representative density than I just talked about. So it's 1.15, it's a number made up. And when you do the conversion, just like I did above here for water, that's the value. Now, it's a density, but as I talked about in other things, it's a density what? It's the grams per liter. So this is the mass per liter. What am I asking for here in this question? I'm asking for the mass of a 2-liter bottle of Coke. Well, don't I have the grams per every liter? You should be saying yes, Mr. Grodsky, yes. Well, if I want a 2-liter bottle, what am I going to do with the value that I just had there? If I have the mass per 1 liter, how do I get 2 liters? Well, you times it by 2, silly rabbit. So to answer the first question, all I have to do is take 1,153, this is grams per liter, watch the units, okay? This is grams per liter, and what do they want? They want it per 2 liters, so I'm timesing by 2, all right? And if I times it by 2 liters, watch what happens, party peoples. Liters cancel, and I'm left with what? Just the grams. Now, people say, well, can I use this one? What about 1.153? Sure. If I use 1.153 grams per milliliter using my units, okay, now to get to 2 liters, how many milliliters do I need? I know that 1 liter is 1,000 milliliters, right? So 2 liters is equal to 2,000 milliliters. So my friends in chemistry, if this is per what? Grams per milliliter, okay, then I have to times this by what? Okay, think with that. Well, this is going to be milliliters. This is the grams per milliliter, times this by 2,000. Okay, density per liter, and of course that would give me the same answer. So that's how I'm doing, all right, that question. Now, number 2, very important. Calculate the number of grams of sugar that are contained in a 2-liter bottle of Coke. And this is so very important. If you're tuning out, Mr. Grodsky, I don't want to hear these in class, put your head up, listen up. This is the crux of the entire lab. We're trying to find grams of sugar. We're using a very important assumption. Okay, what's that assumption? I know what happens when you make an assumption. You make a donkey out of you and me. The assumption is that regular Coke and Diet Coke have the exact same formula of ingredients, same amount of ingredients, except one has sugar and one does not. So we're going to say the difference in these masses is the sugar. That's how we come up. Now that's an assumption that we're going to test the validity of this lab. So the main crux of this lab, focus people, is that we're going to see if, in fact, we get the right number of grams of sugar from a can of Coke, and we're going to test to see that, hey, does Diet Coke and regular Coke have the same amount of ingredients except for the sugar? So how do you get grams of sugar in a 2-liter Coke bottle? Okay, what you're going to do is you're going to do the same thing here. Whatever mass you got for the Coke, you're going to find for Diet Coke. So you're going to have to find the mass for 2 liters of Diet Coke. And once you have that, okay, this is the mass of 2 liters. For Diet Coke, this would be the mass of 2 liters for Coke. All right? Well, if they have the same ingredients except for the sugar, then all you got to do is subtract these two. And when you subtract those two, you're going to get the grams for a 2-liter bottle of Coke. So you're going to subtract these two masses. Okay, and I'll do that over here. So this one minus this one would give me this grams of 2 liters. Okay, very simple premise, but we're going to test that validity. Number 3, how do I get a can of Coke? Because up in front there's a can of Coke that has 355 milliliters, and its known value is written on a nutritional label for carbohydrates. I have the grams of sugar for 2 liters Cokes. How do I par that down for 355? If I know, let's pretend that it was 188 grams of sugar that I found by subtracting the mass of 2-liter bottle of Coke to a 2-liter bottle of Diet Coke, and the difference in the two masses was 188, making the assumption it must be sugar. Guess what I do? Well, this is 188 in 2 liters of Coke, right? All right, and I want how many grams in, well, 0.355 liters, right? This is what we call the proportion. I don't normally do proportions, but that's what we're going to do. This is 188 for 2 liters. How many grams? If you have to use X, people, because the X is always the unknown, solve for your proportion. Crisscross, multiply, and solve for that. You're going to pare that down for 0.355. And of course, you could set that up, what? 2,000 milliliters over 355 milliliters. And of course, that's 188 I have, and solve for X. Same thing, so you're going to pare that down. Okay, last but not least, you're going to go up to see what the known value is on the can, and you're going to do a percent error. That's how we do this lab.